Good day. I think this sheet should be very useful for when you're doing calculation questions. The first three examples relate to different types of calculations related to power, and the last three relate to different questions related to efficiency. So what you see is we have our energy and we have our time, and we want to find power. And we know power is energy divided by time. But we need our power or need our time to be converted to seconds. So the first thing we've done for you is we said 15 minutes multiplied by 60 seconds every minute is 900 seconds. So we've chosen that formula. Now we plug in the numbers from the question. 200,000 divided by the 900. And so we can knock off a couple of zeros there. Get out of the way there. Boom. And we get 222 watts. So you do the work, you write it out like this, you get your 3 marks. Don't forget units matter in your final answer. Number 2 says, how long would it take? Well, that means time. And we know time equals energy divided by power. There's our energy, there's our power. We don't have to do any converting to start off with. So there's our formula. Plug in the numbers, we can do some estimating. If it was a million divided by 1,000, it would equal 1,000. 1,200 is bigger than 1,000, so our answer has to be smaller than 1,000. And it's 833 seconds. Now, you don't have to convert it to the minutes. I just did that to give you some idea what it means by multiplying by, or dividing by 60. Next question. 60-watt light bulb is left on for a week, and we want to know, hey, what is that energy in joules? And what is it in kilowatt hours? Well, energy equals power times time. Okay, let's get that out of there. So first of all, if we're going to go for it in joules, we need our time in seconds. So we have to know how many seconds in a week. So we went 7 days in a week times 24 hours every day times 3,600 seconds every hour. And we get 604,800 seconds. Then we go energy is power times time because it wants the energy. 60 watts was given. We've just figured out the time in seconds. And we get 36,288,000 joules. Now we know we could take this and just divide by 3.6 million, or we can start from scratch. So we're going to start from scratch. We know our energy is going to still be power times time, but our power has to be in kilowatts, and our time has to be in hours. So we need to know how many hours in a week. And pretty well everyone knows there's 168 hours in a week. So same kind of conversion for time. Then we plug in those numbers. Energy equals power times time. Take those kilowatts. And we get 10.08 kilowatt hours. Again, going from here to here, we could do it in one step by dividing by 3.6 million. So that's our friendly reminder there. So those are 3 examples of 3 kind of questions you can get related to power. Now, you can see this one wants an output, this one wants an efficiency, and this wants an input. So we're looking at 3 kind of things there. So if we are looking for output, we're just going to take our efficiency and multiply it by our input. And remember, our efficiency we have to divide by 100, so it's written as a decimal. So there's the formula. 42% is 0.42, multiply through by the 2.5 billion, and we get 1,050,000,000 joules. Next question says, what's the efficiency? So that's easy. We just go for that formula, output divided by input. Our output was 85, our input was 130, they're in the same units. And we get 65.4%. And the last one is, hey, well, now we're producing 800 kilowatt hours. That's our output, so we're looking for our input. So our input is our output divided by efficiency. So 800 divided by 75%, written as 0.75. So 800 divided by 0.75, we have to get a number that's bigger than 800. and we get 1,067 kilowatt hours. So between that, you really have a sample of the kind of questions I will be hitting you with in this section.